Hello everyone. Today we're going to talk about the Vigenère Cipher and how to use it. So the Vigenère Cipher is a polyalphabetic cipher that encrypts and decrypts text by using a repeating keyword and multiple Caesar cipher shifts to hide a secret message. So it's called a polyalphabetic cipher because unlike a simple Caesar cipher that shifts every letter by the same amount, this cipher actually changes the shift amount of each letter because it's not just working with one row of shifts, it's working with a multitude of rows for every single letter. And which row that you use is determined by what letters exist in your keyword. And we're going to walk through multiple examples of how to actually do this. So for our first example, let's use a keyword. I've picked prong to be our keyword right here. And our plain text will be lovely sunshine because sunshine is pretty lovely outside, especially at this time of the day. So we're going to use this table. First you write down your plain text, and then you're going to place and map your keyword, every letter of your keyword, with every single letter of your plain text. And whenever you do run out of keyword letters, then you simply just repeat the same keyword over and over again until you have matched the length of your plain text. Now when we actually perform the encryption and we generate our ciphertext, we can see this table here. It's called a Vigenère table, and what we're going to do is we're going to find our plain text in the list of columns here and our keyword letter in the list of rows here, and we're going to find where we intersect, and the letter where we intersect will be our ciphertext letter. So for this first letter here, L, it's right here, and we map this column. We find out where the letter P intersects at this column. So for our rows here, we find the letter P here, so we mark that, and we intersect at the letter A, and so the letter A is our ciphertext letter for that very first plaintext letter. And we're going to repeat the same process for O. So we find O, find the O column, and then for our key letter we find R, and they both intersect at the letter F, and so F is our ciphertext letter that corresponds with O. And we repeat the same process for V here, and same process for E and for the rest of the plaintext until we complete generating our ciphertext letters. So our ciphertext here is AFJRRNJIAYWZBR. Now in decrypting, you basically perform the reverse operation. So we still use the same key prong. We have this cryptic ciphertext here. We don't know what it says, but we want to find out. And what we're going to do is we're going to lay it all out at the top here. We're going to map the keyword to every letter of the ciphertext, as we did earlier when encrypting. And what we're going to do here is first we're going to identify the exact row for the first letter here, which is P, and then in that row we're going to look for the corresponding ciphertext letter, which is Y, which is right here. And then we're going to identify which column of the plain text letters here that ciphertext letter corresponds with or aligns with, which is the J column. And we see here at the top that J is our plain text letter for the first letter Y, and so we put that here. And we basically repeat the same process for R. You see here R for the what is it, for the ciphertext R right here, and the key R here, and it maps the letter A, so we put A there. Same thing for letter A here, which maps to M, and so on and so forth until we fully decrypt every single letter in our ciphertext. And so our decrypted message is James is culprit. Now, working with the Vigenère table is pretty tedious and takes quite a long time, especially when you're working with a large message. So what you can also do is you can use indices for every single one of your letters, and you can assign a number for them, starting with 0 for the very first letter A and 25 for the last letter Z. And if we're going to test this, we can have plain text. We'll use lovely, first word of lovely sunshine from our earlier example, and we'll use the same keyword that we've been using this whole video. And what we're going to do now is we're going to map every single one of these letters in the plain text and keyword to their corresponding index values. So for lovely, we get these numbers here, and then for prong, we get these numbers here. You'll notice that the last number 15 is just a repetition of the letter P. And so now what we're going to do is we're going to sum the plain text values with the repeating keyword values, and we're going to get our ciphertext numerical values. Now you'll notice that some of these numbers here for the ciphertext are actually overflowing. Like they're not, we do not see them here in our table. They don't really map specifically to any letters that exist in our table. And what you do in a situation like this is you remember that they actually wrap around the table to the beginning whenever you have big numbers like this. So for the number 26, right after 25, index 25, which maps to Z, 26 should wrap around to 0, which maps to A. So that should be corresponding with the letter A. Same with 31. If we start at 25, it goes to 26, 27, 28, 29, 30, and 31. That's index number 5, which maps to the letter F. And you don't have to do this manually for every single one of these. You can just add 20 or subtract 26 from every single one of these overflowing numbers, and that will give you the correct values that you can map directly to every single one of these letters. And now we have our values, our index values for our ciphertext, and our encrypted message is AFJRRN. To decrypt in the same manner, you basically do the exact opposite steps. And so if we use our ciphertext from the previous example, we can use the same key and we'll map our ciphertext values to their corresponding index values. Same with our keys. And this time we're going to subtract the key numbers from the ciphertext numbers because we're decrypting. And you do the same for all of these and you get these values. Now you'll notice you got negative numbers right here. Well, we have negative numbers, and in the same manner those would wrap around to the very end. So I suppose here you have 2. So if you were at A and you wrapped around, you would end up in Y for 24 because you'd have 1-2 steps. So when decrypting, you're going to add 26 to these values in order to get the right index values that fall within the range we want. And then when you do so, you'll get the correct numbers that correspond with your decrypted message. And when we map these back to their corresponding letters, we get our decrypted message, which is lovely. So I hope you learned how to use the Vigenère cipher from this video, and thank you for watching.